Excessive current on a CATV cable can stem from several potential sources. Firstly, improper grounding is a significant factor. A faulty ground connection at the building entrance, the outdoor connection point, or the water main can lead to current leakage onto the CATV cable. Secondly, damaged cables or connectors can be the culprit. Breaks or cracks in the cable itself, or loose connections, can cause a short circuit and consequently increase current flow. Thirdly, defective equipment within the CATV system can introduce current. An internal fault in a splitter or other CATV equipment can lead to current leaking into the system. Fourthly, the proximity of CATV cables to power lines can induce current on the cable, especially if they run parallel to each other. Fifthly, lightning strikes in the vicinity of the cable can damage it and cause current leakage. Sixthly, an overloaded system can cause excessive current. Running too many devices in the CATV system may exceed its capacity and result in excessive current. Seventhly, an incorrect signal level, whether too high or too low, can also be a source of current leakage. When troubleshooting excessive current on a CATV cable, a systematic approach is essential. The first step is to check the grounding. Verify that the outdoor connection point is properly grounded and that the ground lug is tight. It is also important to inspect the water main ground connection and clean it if necessary. The second step is to inspect the cables and connectors. Thoroughly examine the CATV cable and all connectors for any signs of damage or loose connections. Replace any defective components that are found. The third step involves testing the equipment. Disconnect all devices from the CATV system and test each one individually to identify any faulty equipment that may be introducing current into the system. The fourth step is to reduce the signal level if it is excessive. In this case, it may be necessary to contact the cable provider to adjust the signal level. The fifth step is to check for interference. Inspect the cable path for proximity to power lines or other sources of electrical interference that could be inducing current on the cable. When checking the grounding, it's important to understand how grounding systems work in electrical systems. Grounding provides a safe path for fault current to return to the source, which allows overcurrent protection devices, such as circuit breakers or fuses, to trip and de-energize the circuit. In the context of CATV systems, grounding helps to minimize the risk of electrical shock and equipment damage. The ground wire should be connected to a grounding electrode system, which typically consists of a metal underground water pipe, a ground rod, or ground plate. The National Electrical Code, or NEC, provides detailed requirements for grounding electrode systems. When inspecting cables and connectors, look for signs of physical damage, such as cuts, abrasions, or corrosion. Also, check for loose connections by gently tugging on the connectors to see if they come loose. When testing equipment, use a multimeter or other appropriate test equipment to measure the voltage and current on a CATV cable. Compare the readings to the manufacturer's specifications to identify any faulty equipment. When checking for interference, look for any sources of electrical noise that could be interfering with the CATV signal, such as fluorescent lights, motors, or transformers. Keep in mind that the cable company may have additional diagnostic tools and experience to assist in troubleshooting the issue. It is advisable to consult with them if the problem persists. In residential electrical systems, several factors influence the behavior of electrical current. Firstly, voltage is a critical factor. Voltage, measured in volts, is the electrical potential difference that drives the flow of current through a circuit. Common voltages in residential settings are 120 volts for lighting and small appliances, and 240 volts for larger appliances like ovens and dryers. Secondly, amperage, measured in amps, is the measure of electrical current flow. It represents the quantity of electrical charge flowing past a point in a circuit per unit of time. Circuit breakers are rated in amps to protect circuits from overcurrent conditions. Thirdly, resistance, measured in ohms, is the opposition to the flow of electrical current in a circuit. The higher the resistance, the lower the current flow for a given voltage. Resistance is affected by the material and size of the conductors in the circuit. Ohm's law describes the relationship between voltage, current, and resistance. It states that voltage equals current multiplied by resistance, of volts equals amp6 ohms. This law is fundamental to understanding and troubleshooting electrical circuits. The National Electrical Code, or NEC, provides comprehensive guidelines for safe electrical installations. It covers topics such as wiring methods, overcurrent protection, grounding, and equipment installation. Electrical contractors and electricians must adhere to the NEC to ensure the safety of electrical systems. Grounding is a critical safety feature in electrical systems. It provides a low resistance path for fault current to return to the source, which allows overcurrent protection devices to trip and de-energize the circuit. Grounding also helps to minimize the risk of electrical shock. Bonding is another important safety practice. Bonding involves connecting all metal parts of an electrical system together to create a common electrical potential. This helps to prevent voltage differences between metal parts, which can create a shock hazard. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect circuits from overcurrent conditions. These devices interrupt the flow of current when it exceeds a predetermined level, preventing damage to equipment and reducing the risk of fire. Arc fault circuit interrupters, or FSIs, are special types of circuit breakers that are designed to protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. FSIs detect arc faults and quickly de-energize the circuit, preventing a fire from starting. Ground fault circuit interrupters, or GFCIs, are designed to protect against ground faults. Ground faults occur when current flows through an unintended path to ground. GFCIs detect ground faults and quickly de-energize the circuit, preventing electrical shock. Surge protectors are designed to protect electronic equipment from voltage surges. Voltage surges are sudden increases in voltage that can damage sensitive electronic components. Surge protectors divert excess voltage away from the equipment, protecting it from damage. When working with electrical systems, it is essential to follow safe work practices. Always de-energize circuits before working on them, and use appropriate personal protective equipment such as insulated gloves and safety glasses. If you are not comfortable working with electrical systems, it is best to consult with a qualified electrician. Electrical safety is paramount. Always respect electricity and take precautions to avoid electrical shock and fire hazards. NEC specifies requirements for conductor ampacity, which is the maximum current a conductor can carry continuously without exceeding its temperature rating. NEC Table 310.15 provides ampacity ratings for various conductor types and sizes. Understanding conductor ampacity is crucial for selecting the correct wire size for electrical circuits. Voltage drop is the decrease in voltage that occurs along a conductor due to its resistance. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Short circuit current is the high current that flows during a short circuit condition. Short circuit current can cause severe damage to equipment and wiring. Overcurrent protection devices must be able to interrupt the available short circuit current at their installed location. Equipment grounding conductors, or EGs, are used to provide a low impedance path for fault current to return to the source. EGs are typically made of copper or aluminum and are sized according to the size of the circuit conductors. Bonding jumpers are used to connect metal parts of an electrical system together to create a common electrical potential. Bonding jumpers are typically made of copper or aluminum and are sized according to the size of the circuit conductors. Electrical enclosures are used to protect electrical equipment from the environment and to prevent accidental contact with live parts. Electrical enclosures must be properly grounded and bonded to ensure electrical safety. Wiring methods refer to the way in which electrical conductors are installed and protected. Common wiring methods include conduit cable and raceway. The NEC specifies requirements for the installation of various wiring methods. Electrical boxes are used to terminate and protect electrical connections. Electrical boxes must be properly grounded and bonded to ensure electrical safety. Electrical panels are used to distribute electrical power to various circuits. Electrical panels must be properly grounded and bonded to ensure electrical safety. Transformers are used to change voltage levels in electrical systems. Transformers must be properly grounded and bonded to ensure electrical safety. Generators are used to provide backup power during power outages. Generators must be properly grounded and bonded to ensure electrical safety. Motors are used to convert electrical energy into mechanical energy. Motors must be properly grounded and bonded to ensure electrical safety. Lighting fixtures are used to provide illumination. Lighting fixtures must be properly grounded and bonded to ensure electrical safety. Appliances are used to perform various tasks in the home. Appliances must be properly grounded and bonded to ensure electrical safety. Electrical codes and standards are constantly evolving to improve electrical safety. It is important to stay up to date on the latest codes and standards to ensure that electrical installations are safe and compliant. Electrical inspections are conducted to verify that electrical installations comply with applicable codes and standards. Electrical inspections are typically performed by qualified electrical inspectors. Electrical safety training is essential for anyone who works with electrical systems. Electrical safety training provides the knowledge and skills necessary to work safely with electricity. Electrical hazards can be deadly. It is important to be aware of the hazards and to take precautions to avoid them. Electrical safety is everyone's responsibility. By following safe work practices and adhering to electrical codes and standards, we can all help to prevent electrical accidents. When dealing with potentially dangerous electrical situations, it is always best to err on the side of caution and seek the advice of a qualified electrician. Working with electricity requires a thorough understanding of electrical principles and safety procedures. Only qualified individuals should perform electrical work. Improperly installed or maintained electrical systems can pose serious risks to life and property. Regular maintenance and inspections are essential to ensure the continued safety and reliability of electrical systems. Grounding and bonding are critical safety measures that help to protect against electrical shock and equipment damage. Overcurrent protection devices are designed to protect circuits from overloads and short circuits. ASIs and GFCIs provide enhanced protection against arc faults and ground fault. Surge protectors can help to protect electronic equipment from voltage surges. Safe work practices are essential for preventing electrical accidents. Electrical codes and standards provide the framework for safe electrical installations. Electrical inspections help to ensure that electrical installations comply with applicable codes and standards. Electrical safety training is essential for anyone who works with electrical systems. Electrical hazards should be treated with respect and caution. Electrical safety is a shared responsibility. By working together, we can all help to prevent electrical accidents. The information provided in this narration is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work.